Hi, I'm Drew Lucas, part of the Ocean Physics Group, which is part of the Marine Physical Laboratory at Scripps Institution of Oceanography. And this is the Wirewalker wave-powered profiling vehicle. Wirewalker was developed by OPG, the Ocean Physics Group here at Scripps. The Wirewalker consists of three sort of major parts. One is a surface expression. This is our surface buoy. The second is the profiling vehicle itself. And the third is a downweight, which is connected to the surface buoy via a wire. The technique is very simple. Surface buoy, the wire, and the bottom weight ride the surface waves of the ocean. That is, they go vertically up and down with the surface waves of the ocean. This wire, as we'll show in more detail, runs through the middle of the profiler. And inside the profiler is a mechanism that takes the two-way motion of the surface ocean and turns it into one-way motion for the vehicle. We rig these such that the vehicle is pushed down the wire by the surface waves, and when it reaches the bottom, that mechanism inside is released and it floats back to the surface using this positive buoyancy. So now I'm going to walk through each component very briefly and kind of give an overview of how things work. Surface buoy has a number of components. The first component is here. This is a GPS tracker with Iridium communication. So this takes GPS position from the GPS satellites, and then it sends it via satellite back to a server on land so we can locate the buoy. The second is a flasher. We often, when we deploy these in the open ocean and on moorings, use flashers. This flashes only at night so other vessels don't hit it. This part here is the lifting point. It's for both carrying the buoy while it's on deck and for recovery. This is very strong. It's made out of aluminum, and you can attach to here and lift the entire unit out of the water from this point. This is the bottom weight here. This is about a 20 kilogram weight, and we connect this to the bottom of the wire via a set of shackles and swivels. And one really important point is that every single connection point in a Wirewalker system must always have a swivel. All right, so now we're going to demonstrate the setup of the Wirewalker vehicle, including the wire. And just again, as an overview, this is the surface buoy. We've got the wire that's attached to the base of the surface buoy. It'll then run through the Wirewalker vehicle. You can see now the Wirewalker is open, and you can see the wire running through the vehicle. This is the cam mechanism that turns the two-way motion of the surface waves into one-directional motion for the vehicle. The wire exits the bottom of the vehicle and is finally attached all the way down to the bottom weight. So this is a Seabird 49 CTD. The intake of the CTD is here. This is where the thermistor is. The conductivity cell is in this volume, and then this is a pumped instrument. So we've mounted this on purpose at the top of the vehicle with the CTD sensing portion just clear of our upper rail. This allows unmixed water to enter into the CTD. One of the advantages of this unit is because it's free rising, it rises very steadily, and so we can get very high vertical resolution. We've mounted this using an instrument tray, which we've put a circular hole in at the size to accommodate the CTD. We use hose clamps then to keep the CTD from moving up and down relative to the instrument tray, and these are bolted on the rail. And finally, the outer cowling material has bolts in it that holds it into the instrument trays, giving a lot of stiffness to this whole thing. So it's quite a strong mount, and with these instrument trays, you can accommodate any diameter of instrument up to probably about 6-inch diameter things. Now I'm going to show you how to insert the wire into the Wirewalker vehicle. The wire must pass through the middle of the vehicle. The first thing that it encounters are these rollers, these roller trays. So we must remove the top roller tray in order to get the wire in. So we remove the the roller tray by simply pulling up on these tabs and then pulling the tray loose. Wire drops in directly vertically, repositioning the tray such that it slides over on these studs. Once it's seated, these latches hold the tray in place. Okay, now I'm going to show you how to load a wire into the cam. This cam already has a wire loaded in it, so first I'll take it apart. We've got 3 pieces here. Again, this is the top keeper bracket, the race, and the base plate. So the first thing we do is remove the top bracket, lift up on these tabs, pull the bracket forward, lifts up vertically, move that aside, take the race off, then the wire can be removed from the wire walker. Putting the wire in is, of course, exactly just the opposite. You've got this open, lay your wire down on the cam. The key is that the wire get in between these wheels and that the whole thing is seated properly. So typically what I do is just try to make sure I've got it in there, slide the wire. You can see that this is all flush. Put our keeper back on here, slide it forward until it snaps. Make sure this is free to move, and the wire moves, and you're done. So the wire walker, of course, is ballasted to float up to the surface. We've got the door open here. Of course, in the water, it would normally be, the door would be closed. Once the wire walker reaches the surface, the upper turnaround stop enters the vehicle, and it collides with the cam mechanism. Now we've put the cam into a downward mode. It's these springs here that have been now released. This is held down by gravity, and the way this works is that now that it's in a downward mode, the wire can pass moving upwards, because you're pulling the race up into the open part of the jaws, but not downwards, which is pulling the race down. Gravity and the motion of the wire is pulling the race down into where it's pinched. So if you can imagine the surface buoys moving up and down in a circle, it allows the wire, this cam direction allows the wire to pass upwards, but not downwards. Upwards, but not downwards. So that has the effect of ratcheting the vehicle downwards. Once we've reached the bottom, the exact same process happens in reverse. The vehicle encounters the bottom stop, snaps it into an upward mode. Now the wire is completely free, and the vehicle rises under its own buoyancy. All right, now that we've finished inserting the wire through the rollers and the cam, the final piece to do is to secure the lid. The lid has these brackets that slide over studs that come out of the walls of the wire walker. So we just want to make sure that that is seated, slides up, such that it's now on those studs. And then the final piece is to use these screws to secure the lid. And you want to make sure that you've got it all the way secure. So the way that we ballast these vehicles is we use this is a deep pool here at Scripps Institution of Oceanography. For instrument testing, I've ballasted these in harbors or actually in swimming pools. But the goal is to get a rise rate that we're comfortable with. We typically aim for somewhere between 30 and 50 centimeters a second, depending on conditions. Here's the upper stop and the wire. You can see the vehicle is floating in the water. That's number one, which needs to float. So this is the first test, that we have enough buoyancy to make it float. Now what we're going to do is we're going to lower the wire till the stop enters the vehicle and engages the cam, and then I'm going to use my hand power to simulate the surface waves. We're going to drive it down to the bottom, and then we're going to watch the rise rate and see if it's in the range that we want it to be in. So here's the cam, the stop going in and engaging the cam. Okay, we are there. And so there the wire walker cam has been engaged. You can see on the surface waves, I'm pulling the weight upwards. The vehicle is going down because the cam is turning the two-way motion that I'm inducing into vehicle motion in one direction. It's on its way down now. There, it's hit the bottom stop. And now you can see it's rising under its own buoyancy. It's completely decoupled from the wire. So its rise rate is independent of what's happening at the surface. This is a pretty good rise rate, maybe a touch fast. And there it's hit the stop and is on its way down again. That's probably ballasted a little bit positive for our typical uses. We probably would do maybe one piece of foam less. Again, totally decoupled from the wire, so the rise rate independent of what's happening to the surface buoy. This has been a wire walker instructional video. Thank you very much for watching. If you have any questions, please don't hesitate to contact us at Scripps Institution of Oceanography. Thanks.